University, Chennai. Dear ma'am, thank you for being here today with us. She is specialized in multimedia and doctorate in natural language processing. She is the Deputy Director, Attestation Officer, and ISTA President in Anna University, Chennai. She has published 36 research papers in international journals, 16 research papers in 53 research papers in conferences. She has completed 5 sponsored projects. She has honored with Young Leader Program given by Ministry of Youth Affairs and Sports Government of India. The meeting applications and research challenges of Dr. Timala would be an eye-opener for research-oriented computer applications. As you all, I am also eagerly waiting to listen to her. Let me join you all. Hearty welcome, please, ma'am.
Good afternoon to one and all present here. I really thank Wales University for providing this opportunity. So this is an FDP, I think. So let me just share my screen. AR technology and what is a VR technology. Okay, AR technology is to overlay the real images with data or digital images to increase the impact or to enhance the understanding onto real life objects. So AR basically is overlaying the virtual objects onto real environment. That is what your AR is. Okay. So what is virtual reality? Virtual reality is a computer technology that replicates an environment, whether be real or imagined environment, and simulates a user's physical presence and environment, allow for user interaction. Basically, this AR and VR are two different technologies. In AR, I said you create some virtual objects and place those virtual objects in real life environment. Whereas in VR, it is exactly the reverse. You try to create the virtual environment and you try to place all the real life objects onto the virtual environment. Okay, so these two are actually contradicting each other, but using these two technologies, it is possible for us to create some kind of, we try to create some kind of immersive experience for the end users. So if you look at the characteristics of this VR, you create some kind of environment and simulation. The end user will have a presence, so their presence in the virtual environment, and the end user will also feel as though he is interacting with the virtual environment. Okay, so if you look at the immersion level versus the consumer accessibility with respect to AR and VR. So before this AR and VR had started, it was only a 360-degree video that was presented to the end user to have some kind of immersive experience. So if you look at the immersive experience available in the case of 360-degree video, the level of immersive experience is very less when compared to that of virtual reality. In case of virtual reality, the immersive level is huge. Okay, so that's why if you look at in the x-axis, the immersive level is placed, and the y-axis you have the consumer accessibility. Okay, so the immersion level is very much in the case of virtual reality. It is better in the case of augmented reality, whereas it is very less in the case of 360-degree audio or video. Whereas in the case of accessibility, 360-degree video accessibility is very better. When compared to that of VR accessibility, because in the case of VR, we need to have some external hardware components that are needed to view the VR actually that has been created, or to have an immersive experience of the VR application that has been created. So that's why the consumer accessibility is very less in the case of VR, whereas it is more in the case of 360-degree video component. Okay. So as I said, in the case of the mixed reality is a combination of your real environment and virtual environment. Okay, you try environment and you try to create some kind of mixed reality experiences with the help of augmented reality as well as virtual reality. Okay, so here you have the real environment, here you have the virtual environment. So in the real environment, if you try to place some kind of virtual objects, you call it as augmented reality. Okay, in the case of virtual reality, you try to place the virtual objects onto the to place the real objects onto the virtual environment. Okay, so if you look at the AR versus VR, say the revenue capital and the industry expansion in the case of AR, if you see, it was about 90 billions, and then in the case of VR, it is about 30 billions. Okay. So which means in future, this is going to be the state of art technologies. So there are different types of VR as well as AR. Let us have a look into what are the different types of VR as well as AR. What are the components? As I said, in the case of virtual reality technology, we need to have some extra additional hardware components to view the virtual environment that has been created. Okay, so you need to have, say, what are the key technologies that are used in virtual reality is autonomy. That is, you need to have some kind of tracker which can track your head movement, and you also need some kind of intelligent system which can monitor where exactly you are moving. Okay, and moreover, you can have a lot of interaction. Okay, with the help of some specialized gloves that you wear in your hand, as well as with the help of the head-mounted devices which are called as HMDs that you wear in your head. Okay, using this, it is possible for me to interact with the virtual objects that has been created. Okay, so you try to create graphics, you also try to create audio, and you have some kind of multisensory output. Okay, so you need to have multisensory displays in this case, like visual has to be seen, the audio has to be heard, the haptic in the sense, the feeling of touch. Since you're wearing a specialized gloves, it is also possible for you to have some feeling of touch. Whenever you try to touch certain virtual objects, you will have a feeling as though you're touching the real objects. And similarly, the olfactory is the sense of smell. So nowadays, to have to create some kind of realistic environment, what happens is they also create the kind of sense of smell is also created. Like whenever you new some new environment or new rooms or something, you will have a pleasant smell. Okay, so the olfactory is also one of the key elements which try to create some kind of the smell kind of environment. Okay, so when it started in the year 2010, where Palmer Lucky was a person who tried to create this head-mounted devices. Okay, he tried to create the head-mounted devices, and he created the mixed reality lab. Then 2011, the Oculus Rift was one of the type of HMD that was invented. Okay, so it was a Kickstarter, and when it started, it was about 2.4 million. Okay, so it was 2012 when it started. Then 2014, the market value expanded to about 2 billion. Okay, so in 2014, the company was acquired by Facebook. So if you look up what are the different types of VRs that can be created, the desktop VRs that was created in the year 2016. Okay, so if you look at the desktop VR can support, previously when it was created, it can support more than 4 billion polygons per second. Okay, so that means the rendering speed of the desktop is going to be more than 4 billion polygons. See, whenever we try to create graphics onto the screen, you try to create the graphics using mathematical formula, which are where the three-dimensional objects are being created by stitching the polygonal objects or polygonal patches, by creating some kind of polygonal patches. Whenever I want to create a wall, or whenever I want to create some kind of 3D realistic object in the desktop, what I do is I try to patch or I try to stitch the polygon objects, and I try to create those three-dimensional objects. So when I do this kind of patching, what happens is the surface has to be the ball has to be viewed in the form of a ball only. Okay? So it should be very smooth. For that, we have various shadowing effects that needs to be applied to the object, as well as rendering methodologies that are supposed to be applied to the object. Okay, so which means your desktop should be possible to handle that many number of polygonal objects, and it has to render those objects onto the screen. So previously, when it was in the year 2016, it was about 4 billion polygons per second it was possible for it to render about 4 billion polygons per second. Okay? Yeah. So these are various. If you look at the VR technology, we have two different types of VR technologies. One is a desktop-based VR technology. The other one is a mobile-based VR technology. In the case of mobile-based VR technology, this is a kind of hardware device that you need. Okay, wherein I think people will talk about something called as Google Glasses, isn't it? Those are all mobile-based VR technologies. So you can place your mobile phone inside this hardware kit. Okay, inside this hardware, you can place your mobile phone, and you can just view or you can view the scene using that particular hardware device. So that is your mobile VR. Okay, whereas in the case of desktop-based VR, you have your desktop at one certain distance, and you try to stand in some specific room or something. Okay, you will have trackers or that are placed inside the room, which can sense or which can track the motion of the human being, whoever is viewing that particular or whoever is viewing that particular scene. So the movement of the user is being tracked, and based on the movement of the user, the objects will be shown in a realistic manner inside the virtual environment to the end user. Okay. So that is in the case of a desktop, for which you need to have, they want to go to that particular location or not. Okay. So where this augmented reality in tourism, what are the domains in which it is used is for marketing, for hotel bookings. You can show the hotel room itself. You can see in an augmented reality manner. You can visualize the entire hotel room. Okay. So you can have some kind of enhanced navigation in this. You can have language translations. So the description of the entire hotel room can be given in the form of text as well as in the form of audio in different languages also. Dining and entertainment planning. In dining and entertainment planning, you can use this augmented reality. Okay? So turn the vacation into a realistic experience. Next one is AR and education. So nowadays, due to pandemic, we know that how this educational industry, it has been totally affected. So everything now goes online, in an online mode. The students are sitting in some location, they are sitting at the homes, they are just listening to, whether actually the students are listening to the lectures or not. So what we can do is you can create an avatar of the entire, the staff member, and the avatar can be placed in each and every individual human's cabin or individual student's cabin or student's location, and the student will have a feeling as though the real staff member is teaching to him, the real staff member is standing in front of him and he is teaching. So that is a kind of experience that you can give in the case of AR. Okay. So in educational settings, AR has been used to complement a standard curriculum. The text, graphics, video, and audio may be superimposed into a student's real-time environment. So what is a student's real time environment? Student, the real-time environment is going to be his house, where he is sitting. You can superimpose all these audio, video, as well as text, graphics, everything can be superimposed in the real environment. Okay? The textbooks, flashcards, and other educational reading material may contain embedded markers or triggers that, when scanned by an AR device, produce supplementary information to the student. So similarly, what you can do is you can have suppose whenever the student scans the textbook in his hand with the help of his mobile phone, then automatically an augmented reality experience he will get. The entire picture or the image will be self-explanatory. It will come in the form of an AR. It will explain itself to the student, so that the student will have a feeling as though the teacher in that particular fact to the student. Okay, so AR enables the student to experience a different learning cycle that will make them retain more knowledge longer. Okay, so as Confucius, he said, "I hear and I forget, but I see, I remember, and I do and I understand." Okay, so whenever I hear something, I may forget it after some time. If I see, I may remember. If I do it with my hand, then it is possible for me to understand it, so that it will be retained better. Okay, so this kind of AR technology can be helpful in creating some kind of virtual labs also, where the student himself, say for example, they want to do some kind of chemistry or physics experiment. So the student himself, using the head-mounted devices as well as the gloves, he himself can catch hold of the burette or pipette, or he himself can do the experiment, and he will have a feeling as though he's really doing the experiment, and he can do it in virtual reality. Okay, so that is a kind of experience that you can give to students. Maybe this is an AR in classroom. See, the entire solar system is being shown to the end user or to the students. Okay, so the learning is actually constructiveness in this case. Okay, so this kind of constructivist learning involves exploration of some kind of pre-built world. Maybe I can show you one video for that related to AR in education. Are you able to see this? Are you able to see this video?
Yes, ma'am. Yes, ma'am.
Yeah. So that is how you can see how the students were able to really explore the objects. Okay, so in the case of AR, as he said, you doesn't need any kind of extra sensory devices or anything. It is enough if you can have a mobile phone with a camera. That is enough so that you can have the real AR experience. So that is the advantage of this AR. Okay. Yeah, so this is AR in classroom, what we have seen. Similarly, VR can also be used in education applications. Okay, as I said, the student can himself can do the experiment and see. Okay, in the case of VR. Okay, so VR educational applications. See, this is a kind of virtual hand. So using the virtual hand, it is possible for the student to touch and feel the entire objects that is being placed in the universe. So another example of exploration-based learning is a virtual physics laboratory to teach high school students, okay, the quantum physics and all those things. Students interact with the simulation using a sensing glove on the virtual control panels. So you can also create virtual control panels, and using these control panels, they can just it is in the form of a menu, so the student can use a virtual glove or the real glove to select the particular menu, and automatically the entire VR experience. The students are more motivated and understand the 3D concepts better compared to other methods of instruction. Okay, so this is also another one example for VR and educational application. So constructivist learning involves active building of a world. An example is a nice project to teach gardening to elementary school children. Use a cave and the immersive disk to interact with the virtual elements, showing a virtual garden. So what the elementary kids can do is they can use the sensing glove as well as a head-mounted devices so that they can interact with this is an example virtual garden that has been created, so they can interact with the objects that are created. They can touch the objects, they can feel the objects, and they can move the object from one location to another location. So in this case, they are telling that the student himself can create a virtual garden basically. Okay. So the system was also tested with about 52 second grade students, second standard students. They were divided into groups with a leader that interacted with the simulation. The garden had avatars to represent the team leaders and the intelligent agents. So this is a kind of avatar that is being placed. Okay, you can see the student is wearing the head-mounted devices, and he is also having the sensing glove in his hand. The percentage of children understanding the gardening concepts went from 12% to 35%. Okay, they also did a research, and with the 52 second standard students, and they found that the understanding, the amount of understanding that went from 12% to 35%, which means that more number of students were able to understand as well as were able to conceptualize the concepts better. Okay, most being the team leaders. Similarly, you can also go in for AR in medical education. In medical education, the phrase see one, do one, and teach one is a creed, but the students become professionals and go on to help the next generation. AR already exists in medical education, and subject areas of AR applications covered include anatomy, surgery, and forensic medicine. Additionally, AR have a place in medical training and already assess in actual medical procedures. So, in the case of medical education, AR will be very much helpful. AR as well as VR technologies will be very helpful. So, what happens is nowadays it is very difficult for us to get the cadavers. Okay. So instead of having the real cadavers, what we can do is we can have some kind of three-dimensional objects that are created, okay, so that the student can perform the surgery on the virtual object. So n number of times the student can perform the surgery, and even if the surgery goes wrong, it is not going to be that much destructive. Whereas the student cannot perform the surgery on a real patient and check whether he is able to perform the surgery in a positive manner or not. So these are, in the case of medical application, it's really wonderful, basically. So even for teaching the anatomy, you can have the virtual human body, or the virtual 3D human being can be placed, so that the medical students can touch and feel. They can find out where exactly what is inside the abdomen, what is there, what is a small intestine, what is feel whatever is present inside the human being's body. They can also do some kind of virtual surgeries onto the available virtual avatars that are being given to the medical students. See how they are able to learn using the virtual object. So internally, all the internal, the skeletal system, the muscular system, the circulatory system, everything is being shown. So wearing this head-mounted devices, they will have a feeling as though they can see it in real life environment, as well as they can, if they wear the hand gloves, they can also touch and feel. Okay? So this is a virtual anatomy that can be shown to, this is a kind of virtual anatomy. See, you have the three-dimensional avatar or the 3D human being. So you can have a view of the skeletal system, you can have a view of the circulatory system, everything can be shown to the end user. And everything can be shown to the medical student. So this is a kind of virtual menu that has been created. Okay, so this is a kind of the student can perform the surgery basically. Okay, he can anatomically visualize the entire bones and other things. So where all this VR is being used in medical application is in the case of diagnostics. For anesthesia, anesthesians can give the anesthesia to the virtual bodies and they can check, okay, whether it is correct or not. Similarly, in the case of surgery, emergency, all these things can be done on virtual. They can test it. They can also perform it n number of times, okay, so that they get enough experience. So even in rehabilitation centers, this kind of VR human bodies are being used. Okay. So this is a kind of virtual surgery that is being performed. The blood vessels are modeled using the Telos spline-based toolkit. The vessels are also textured to increase realism. The trainee holds real surgical tools like tweezers, needle holder. So the trainee will be holding the real surgical tools and he can perform the surgery onto the virtual human body for increased task realism. Okay. So this is in the case of rehabilitation. Okay, in the case of rehabilitation, see, you have the finger actual, you have the patient's hand, so the patient can feel, he can perform the kind of exercise that he is supposed to do n number of times. So the trial number is also given here. Okay. Similarly, training in emergency medical response. Suppose there is some kind of emergency medical response. A bioterrorism has happened and you want to evacuate everybody. So what is the procedure for this kind of evacuation? So those things can be explained to the end user using the AR/VR technologies. Okay. So training in biowarfare response is not practical with the current live exercise method. So no true casualties were very expensive to organize and it is being rarely done. So VR allows casualties to die. So in the case of VR, you can allow the person also to, the virtual person also to die. And it is much cheaper to organize and can be done locally without requiring any kind of EMT personnel to travel away from the township. So you can have some kind of, see, this kind of emergency medical response can be trained or can be given as training to the end users with the help of VR applications. Okay. So the training scenario is airport explosion with casualties and propagation of Staphylococcus enteroxin. That is a germ warfare. See, now in the case of pandemic, we are actually facing this kind of germ warfare. So all these scenarios can be actually, augmented or it can be virtualized and it can be shown to the end user. Suppose if somebody is not going to follow the social distance measures or is not going to follow the precautions for coronavirus, then you can show what will happen if you're not going to follow all these precautions in a virtual environment. You can show the simulation to the end user so that he will really understand what happens. Okay. Because in actual environment, we are not able to see the virus in our using our naked eye, isn't it? So what you can do is you can create a virtual environment and you can show the virus itself to the end user so that he will have the feeling and he will understand the importance of social distance and other things. So AR in engineering graphics, the AR-based engineering graphics system uses normal books as an interface. Students can turn the pages of these books, look at the problem inside the book and finish their assignment much the way they are reading and writing on an ordinary sheet. However, if they focus a camera on the marker, a 3D virtual model pops in the computer screen over the real pages. So onto the real pages, if you can scan the image in the real page or on the real textbook, the virtual 3D object will come out. Okay. The virtual models will be superimposed upon the real page, will serve as a tip for imagining the relationship between the 3D geometry as well as the 2D shapes. Okay. So this is AR and engineering. See, these are the plans that are being created, the 2D plan that is being created. So if you can scan the 2D plan that has been created, you can virtually see the 3D object placed onto the 2D plan. So you can you can slice it and you can see how exactly it looks like. So this is a kind of feeling that we get when we look at engineering drawings. Okay. AR in military, in the case of warfare platforms, also these kind of AR technology is useful. The defense forces from different countries across the globe are embedding the AI as well as AR into weapons and other systems used on land, naval, airborne, and space platforms. Using AI and AR in systems based on these platforms is enable the development of sufficient warfare systems which are less reliant on human input. It was also led to increase synergy and enhance performance of warfare system while requiring less maintenance. AI is also expected to empower autonomous and high-speed weapons to carry out collaborative attacks. So some kind of usage of autonomic weapons or performing the collaborative attacks, these things can be actually trained to the warfare personnel using these kind of AR technology or the VR technology. Okay, so the combat simulation and training. The simulation and training is a multidisciplinary field that pairs the system engineering, software engineering, and computer science to construct computerized models that acquaint the soldier with the various combat systems that are being deployed during military operations. The US is inventing increasingly the simulation and training applications. So some kind of training that is supposed to be given for the military people can be given using this AR and VR technology, where you can create the enemies as 3D objects, place them at some specialized locations. Okay? So, and you can ask the military person to exactly shoot at the 3D objects that are. So really, they are getting trained using these kind of simulative environments. So they will have a feeling as though really they are getting trained using these kind of simulative environments so that they will have a feeling as though they are really fighting with their enemies. Okay. So this is also another one example where you can see he's having the real, you can also make them hold toy missiles and other things in their hand, and they can point to some virtual objects and they can shoot them also. Okay. So AR and entertainment domain, AR, the usage of AR was wonderful. It provides multiplayer VR gaming in Varo space. Okay. So multiplaying VR games nowadays, students are playing, students and kids, okay, they have enough time because they are sitting only at home. So what they do, they play lots of games. Okay, AR, VR technology has really revolutionized this kind of 3D game. Okay, so 3D gaming industry has been revolutionized with the help of this virtual reality as well as augmented reality. Okay, so now looking at the various challenges as well as solution, in the case of AR and VR, you need to have something called as wide area tracking. Okay, as I said, the end user, whoever is wearing the head-mounted devices as well as a gloves in the hand, his motion is supposed to be tracked. Okay, so his the head motion is also supposed to be tracked because as and when he moves the head, automatically the movement has to be tracked and the viewing parameters or whatever scene that he is going to view will also change as per the movement of the head. So every time you need to track the movements of his head, the movements of the entire human being is supposed to be tracked. So wide area tracking is one important aspect that you need to look at. Okay, so then freedom of movement. Okay, so where he is supposed to, how much degree he can move. Okay, whether it is, say for example, in the case of an head, I can move only 180 degrees. I cannot move for a 360 degree. Okay, so similarly for each and every joint and other things, we have some constraints, isn't it? So what is the kind of degree of freedom or degree of movement that you can make? Okay, so what are the constraints that need to be placed? Everything is supposed to be researched. Okay, so similarly the natural interaction, what kind of interaction you can have. Okay, what kind of interaction the end user can have with respect to the virtual objects that are shown in front of the end user. Okay, that is also another one important research area. Okay, as well as the content. Okay, the multi-sensory feedback. Okay, in the case of a custom game platform, what is the kind of feedback that you are going to get? Suppose in the case of a military simulation, when the military person is using the gun to shoot at a particular target, then he will feel in his hand, he will have a feeling as though the pressure and other things will be felt by the military person, so that he will have a feeling as though he's really shooting at the target. Okay, so such kind of multi-sensory feedback also need to be given when it is supposed to be given. What is the kind of pressure that needs to be applied? Okay, all these depends on the various physical parameters. Okay, at what distance he is standing with respect to the virtual object, at what location he is standing, how he is shooting at that particular object, at what velocity that particular bullet is flowing. Based on all these factors, the feedback is supposed to be given, or the pressure is supposed to be given to his hand. Okay, so these are certain challenges that you will face. Okay, so this is some example for VR entertainment applications. The Disney has constructed a Disney Quest, a building full of arcades where it will allow feedback effects for possible at home and multiplayer games. Okay, this is a Pirates of the Caribbean, the motion platform. Okay, you have the tactile feedback is a sense that you can actually feel it. Okay, like haptics feedback. Then you have stereo graphics. So this is a kind of ambient LED lighting effects. So you will have a feeling as though you are really sitting in an fully, in the simulated environment. You will have the end user will have a feeling as though he is fully immersed in the simulated environment. The games are migrating to the cell phones nowadays. These kind of games also come with the cell phones. So you have mobile games also. The Disney also developed the virtual jungle cruise on inflatable rafts. So you have pneumatic motion platforms, sensorized oars. Okay, the oars will be sensorized and the water sprays add to the feeling of immersion. So it is like you are traveling in a sea or a river. Okay, you have a raft, you sit in the raft. The raft has some kind of like motion sensor. So whenever you try to move or whenever you move in the sea, the water also splashes onto your face. So you will have a feeling as though you are really sitting in the river and you are moving. Okay, so that kind of presence or immersive feeling it gives. Okay, this is arts application for VR, a 3D viewer allowed interactive frame rates at a laptop for art historians. Okay, so the art handicrafts that are available in the museums, you can show it, when it is not possible for everyone to go to the museum and look at the artifacts or the handicrafts that are placed there. So what you can do is these kind of virtual museums can be created in airports and other locations, so that the foreigners, whoever enters into our country, he can have a look at the various historical places, various handicrafts and antiquarafts that are available in our museums using some kind of VR technology. Okay, so this is an archaeological historical location that has been created using VR. Okay, this is you call it as a virtual heritage. So this has been made out of 59,000 polygon interior. For interiors alone, they have used about 59,000 polygon. Okay. Basically, these kind of 3D objects are being created by stitching various polygons together. So when I try to create these kind of 3D objects by stitching various polygons together, I have to see to that it has a real life feeling. Okay, it looks exactly like the real museum or the real heritage location. Okay, so in that way, I have to stitch everything, and that way it is supposed to be rendered onto the scene. That way it is supposed to be shaded. So there are various, I think, people who are good in graphics, they could have heard about various shading models and other things like found shading, Doran shading, flat shading. Okay, where found shading is a best shading methodology. You will have, in the case of found shading, it gives some kind of realistic appearance to the objects that are being created. Okay, so this is a virtual Notre Dame, the best known church in Europe. Okay, which has been created using VR technology. Okay, so it was modeled using the Epic Unreal Engine. Unreal Engine is a tool that has been used to create or to model this Notre Dame. This is a screenshot of that. So you can have a virtual tour with a guide who is an avatar. So the guide can also be an avatar, and you can have some kind of virtual tour inside this. So an AI engine drives the behavior based on the input from the proximity sensor placed at various locations inside the virtual cathedral. So this is a virtual cathedral. Lots of sensors will be placed inside the virtual cathedral. There are trackers which are being placed here and there. So whenever you try to move inside the virtual location, it will track you, it will track the movement, the leg movement, it will track the head movement and other things. And automatically the viewing and other things also varies based on your head movement as well as the leg movement. Okay. So AI and AR, VR, augmented reality and artificial intelligence are distinct technologies, but they can be used together to create some kind of unique, realistic experiences. Independently, however, AI models have gotten incredibly good at doing many of the things required to build immersive AR experience. It is possible for me to create some kind of immersive experience using the AR technology. To make those objects behave in an intelligent manner, we need to incorporate AI into the AR objects that has been created. So deep neural networks can detect the vertical as well as the horizontal trails. They can estimate the depth and they can segment the images for realistic occlusion. Occlusion is a case where some of the objects are hidden. I have modeled some about 10 objects. I am placing all the 10 objects onto the scene. Okay, so not necessary that all the 10 objects are supposed to be shown to the end user. Some of the objects may be hidden because some objects may be placed in the front, some objects may be placed at the very back. So what are the faces of the objects that are hidden? Which face of the objects are hidden? Those you need to apply some kind of hidden surface illumination algorithms and all those things so that you can eliminate those kind of hidden surfaces and show only the visible surfaces to the end users. Okay. So in all these cases, you can apply the AI technology, so like your deep neural network or your neural network or some kind of machine learning algorithms to make the objects work in an intelligent manner. Okay, so because of all these abilities, the AI models are replacing some of the more traditional computer vision approaches underpinning the AR experiences. So where this AI and AR VR can be integrated, here are certain scenarios or cases that I have given where this AI as well as an AR and VR can be integrated. Okay. So image or scene labeling. A camera frame is run through an AI model that classifies an image. There is an AI model which can classify an image. So what I do is the classification triggers an AR label for that particular location. Okay, so this is an integration of AI as well as AR and VR. So there is an AI model which can classify. I give an image, automatically the AI algorithm will classify what is the kind of image it is. So this is an AI technology that has been used. Now, over and above the AI technology, what I can do is I can give certain description about that particular image over the object in using the AR technology. So thereby it is possible for me to integrate or unite this AI as well as AR. Similarly, in object detection, a camera frame is passed to an AI model that estimates the position and extent of objects within the scene. Okay. So the object is placed, what is the position of the object and which location it is placed, all these things can be understood using an AI model. Now, this location information is then used to form hitboxes and colliders that facilitate interaction between physical and digital objects. So whenever I try to place the digital, whether collision will occur or not, so what is the kind of collision that is going to occur, everything can be incorporated or can be found out using the AI as in of AI and AR technologies. So AR kit may provide generic people occlusion capable cars on other objects. Okay, so you can apply AR plus AI. Using AI, it is possible for me to understand whether those objects are occluded objects. Now, using AR, it is possible for me to create an augmented car or something, augmented 3D model of that entire object, and you can just cut the car into pieces and you can understand the inside of the car. Okay, you can do some kind of semantic segmentation. AI model infers the position of objects with hands and fingers, which are used to control the AR content. Okay, so there is an AI algorithm which will understand the position of the hand, where exactly the finger is placed, what is the kind of grip that I am using. Everything is calculated using the AI algorithm. So this can be used for me. This can be used in an AR environment to handle the AR objects or the digital objects. Similarly, text recognition and translation. An AI model detects, reads, and translates the text in an image. Okay. In an image, we even have text information. Those text information can be read, like how in the case of OCR. OCR itself is an intelligent application, isn't it? So with the help of these kind of AI-based intelligent application, you can convert an text that is placed in an image, you can convert it, you can read it, and you can understand the text. Now, you use augmented reality APIs or then used to overlay the translated text back into the 3D world. So this, you scan the image, you give it to an AI model. If the AI model will understand the text that is present in that particular image, now you convert this text into some 3D digital object and you try to apply overlay this text onto the digital objects that are being created. Okay. Similarly, audio recognition. Okay. AI models listen to specific words that trigger the AR effects. For example, your user says the word queen and automatically a virtual crown appears on their head. If I want to look like a queen, I just tell I'm a queen, automatically virtual crown will appear on my head. Okay. So these are certain example or cases where AI can be integrated with AR and VR applications. Okay. While the debate over the AR versus VR versus mixed reality is ongoing, the augmented reality is a unique opportunity for designers to create apps using image, object, and color recognition. Just like AI leverages the data to make decisions, AR leverages the recognition of key anchor objects and points within a given space. A great example of a perfect combination between AI and AR is Apple's Animoji. This is a perfect example of integration of AI and AR. This animated emoji for the iPhone X. According to Apple, this Animoji is a custom animated messages that use a voice and reflect your facial expression. The Animoji that is being used in the Apple iPhone X, okay, that is a best example of AI integrated with AR. Okay, so where this Animoji can easily understand your facial expression, it will understand in what kind of mood you are, it will understand what you are talking to it, in what sense you are telling, in what, you are in which state of emotion, everything will be understood by this Animoji, and automatically it reflects the same to the end user. So the rendering and the animation work in the real time thanks to the iPhone X is scanning features. Okay. Augmented reality can also be used for knowledge transfer, such as training in industrial environments. Instead of explaining or imagine showing a worker how to do a specific task, they are using an in-context video. This opens the doors for designers in the e-learning area to create next-generation AR interfaces. Okay, so Boeing uses an AR glasses powered by Skylight to guide the technicians as they wire hundreds of planes a year. Whenever you try to wire planes, they use this kind of AR technology to teach the people who are supposed to do that work. So the wearable display helps the technicians identify and accurately connect hundreds of wires using only the sight and voice to control the app. Okay. So as a result, Boeing has cut the production time by 25%, and it has also lowered the error rates. Because if you see, look at the wires, how thin the wires are. So it uses here the AR technology is being used. It will help the technician to understand which wire is supposed to be connected to which particular location or to which particular component. Okay, so by this, he says Boeing has reduced the production time, and it has also reduced the error rate. So this is a kind of training that can be given to the, in the industrial domain, basically. Microsoft giving holograms a real-world context and scale. Okay, using this Microsoft HoloLens, it is possible for you to create some kind of virtual avatar standing in front of you itself. So I can talk to somebody who is, suppose I am using a mobile phone to talk to my friend who is in California. I can see the real virtual avatar of that particular person standing in front of me and talking to me as though I am talking to him in a real manner. Okay, so that is a kind of improvement that has come. So the MR technology mixes and blends a person's physical surrounding with objects from the physical as well as the digital world together. Using this MR technology, we can interact with both digital content and the world around us, as well as interact with some kind of 3D holographic projections. Okay. See, look, this particular person is talking to a virtual avatar. Okay, the person who is sitting in front of him is not a real person, but actually he is a virtual avatar who is sitting in front of him. So he is discussing with this particular virtual avatar as though he is discussing with a real person. So they have the PPT or the presentation is also shown in a virtual mode to both of them. So they can interact with this virtual presentation, and they can do what kind of whatever kind of interaction they can just move the objects that are there available in the screen also. So the future is virtualitics, which provide data visualization in VR and AR environments through machine learning and AI. So the future of this AR and VR is integration of AI into AR and VR environments. So you call that as virtualitics. These technologies or tools that help us tell stories and share information like never before. They can be used as an incredibly powerful emotional engagement tools, enabling us to build empathy and connect with the audiences beyond what the TV, computers, or the internet used to do. So nowadays we say that the entire world has come into our hand, which means it is possible for us to talk to anybody who is sitting in the world. Wherever he is sitting, I can talk to him. That is the kind of scenario we have now. In future, it is also possible for me to talk to the person who is sitting in some other, some other part of the world, as though he is sitting in front of me. I can see the virtual avatar of the person sitting in front of me, and I can talk to that particular person. Okay? See, these are certain examples. So the future may also be called as hyper reality, a combination of AI, AR, VR, and mixed reality. So one interesting innovation is done by Escape Labs, which uses augmented reality and mixed reality to create holographic experiences for escape rooms, team building exercises, and room scale puzzle games. The need for clunky handset and the requirement to connect with a static computer will no longer be necessary. Okay. The transition between the virtual and the real world will become easier and quicker using this kind of hyper immersive technologies. We call it as hyper reality. So these are the references that I have taken. Any questions? Any questions that you want to ask regarding AR, VR, or the integration of AI into AR, VR?
Participants, you can post your queries or you can unmute and you can ask your queries. Thank you, ma'am.
I think somebody has asked IKEA whether it is available in India. I think it is available. You can just check it out. You have to ask the IKEA company. Yes. Any questions, ma'am? You can ask any questions related to graphics or multimedia or even mixed reality technology. Anything can be asked. So no questions means either you have understood it fully or you have not understood anything. Yes, thank you, sir. I really thank Wales University for giving me this opportunity to present.
Thank you, ma'am.
Thank you.
That was really an extraordinary speech. Thank you, ma'am, for your rich words. It surely helped us to understand the augmented reality through their intellectual words.
Thank you, ma'am.
Thank you very much, ma'am.
Yes. Can I leave, ma'am?
Yes, ma'am, sure, ma'am.
Yeah. Thank
Ladies and gentlemen, your presence made this day a memorable day. Thank you for listening and for giving your time and making your presence. We will join tomorrow for the second day of International Faculty Development Program, and I am sure we will have a thought-provoking session. Thank you. Participants, kindly fill the feedback link, session 3 feedback link available in the chat box.